Okay, here's lesson 11.4 for Algebra 1. Oh, sorry about that. Algebra 1, 11.4 video lesson, adding and subtracting rational expressions. 3 boxes to talk about. So let's get into this first one here. When we want to add two rational expressions, the thing that we have to make sure of is just like adding two fractions together. We can only add if they have a common denominator, which in this case, these two rational expressions do. So if my two rational expressions have a common denominator, then I simply just add the numerators, so 3x plus x, all divided by one single common denominator of x minus 2. Now simplifying further, 3x plus x make 4x, so I've got 4x over x minus 2, and it couldn't be easier. The only thing that we have to make sure that we are aware of is that our denominators have to be the same if we are adding two things together. That was an example of an easy one. Here's an example of a more difficult one in which the denominators are not the same. If I wanted to add the rational expression 5 over 6x plus 3 over 2x squared, then I have to come up with what's known as the lowest common multiple. And basically that is the first multiple that each denominator goes into. So the way I do it is I look at the numbers 6 and 2, and the first number that a 6 and a 2 both go into is a 6. And then I have an x here and I have an x squared. So the first term that both x and x squared can fit into evenly would be x squared. So then once I've got my lowest common multiple identified, I ask myself, what does this piece need in order to create the lowest common multiple, given that I already have a 2x squared on the bottom? Well, if you see it, I need a 3, just a 3, sorry. I just need a 3 over 3. And the reason is because if I take 3 and multiply it by 2x squared, then of course I would get the lowest common multiple, which would be 6x squared. So this piece just needs a 3 over 3. I do the exact same thing with this piece on this side. I ask myself, what is it that I would have to multiply 6x by to create a 6x squared? And that would be an x over an x. And the reason we can still do this, everybody, is because this is just a fancy 1, and this is also just a fancy 1. So I'm not breaking any rules here. I'm just rewriting them so that they have a common denominator. Okay, so on the top, I'll move this over. I would get this. I would get 5x over a 6x squared plus a 9 over a 6x squared. And now, because my denominators are the same, I'm in the boat that I was in the very first problem, or I can just add straight across. I've got 5x plus 9, all divided by the common denominator of 6x squared. Kind of a medium example there. So there's the whole problem start to finish. Okay, here's one that's a little bit harder, only in the sense that the LCM is not that obvious, but it's also not that hard to come up with. So the lowest common multiple, again, is the first product that each term goes into. And when they are clearly different like this, d minus 1 and d plus 2, then the lowest common multiple is just the product of the two. It's d minus 1 multiplied by a d plus 2. So again, you play what I call the what's missing game, and I ask myself, what is missing from this denominator to make it be the lowest common multiple? And that will be the factor of a d minus 1 and a d minus 1. So again, over here, I've got a d minus 1 and another, I ask myself, what does this piece need? This piece needs a d plus 2 over a d plus 2. And again, this is all legal because this is a fancy 1 and this is a fancy 1, where I have now each created the LCM on both sides. So when I clean this up a little bit here, here's what I get. I get on the numerator 3 times d plus 2 minus 2 times a d minus 1, all divided by the lowest common multiple, which is a d plus 2 multiplied by a d minus 1. Now I just get to simplify a little bit. This will be 3d plus 6 minus 2d plus 2, all divided by lowest common multiple, d plus 2 times d minus 1. And then simplifying a little bit further, 3d and negative 2d just make d. And 6 and 2 make 8, so d plus 8, all divided by d plus 2 times a d minus 1. And that's it. And that's how we do it. Okay, so the key is remembering to get that lowest common multiple and play the what's missing game on each term, create that common denominator, and then proceed as planned. All right, good luck.